This is my video submission for Math 2500 with Professor Simonza, differential equations. So as you can see by the title, I will be covering integral Laplace and inverse Laplace transforms. So to begin, I would give us a definition function of this f prime t subject to a definite integral with the lower bound of 0 and the upper bound of positive infinity, e to the negative 5t, and then once again the first order derivative, and since we are integrating there will be a dt. Okay, we will be integrating by parts, so just looking at this right now, we will have to use a u, a du, or a u prime, a v, and a v prime. So I'll just set these aside right now. U prime is equal to negative 5e st. And then for v is this is the function, and then the derivative v prime would become just f prime of t, which makes sense. So further looking at our definition function, you can see that because of our definite integral, we will have a limit as b approaches infinity. And just rewriting this here, be e st times the function, again, as b as our upper bound, and 0 is our lower bound, sorry, minus our integral of 0 over lower bound to positive infinity, our function once again, f of t, and we multiply this by our u prime. As we can see, it is se st dt. Okay, and this whole thing should become, let's see here, so because we have a lower bound of 0 and an upper bound of b, and we're subtracting the integral of 0 to positive infinity, this should become negative f of 0 plus our du, so s times positive, or capital F of s. So now we can start using our transforms. So we have f prime of t is equal to s f s. I'm just rewriting the equation above. And further, for our second order derivative, will become this. So as you can see, it's just everything raised to the second power because it is the second order derivative. Now, we'll be solving a homogeneous, we will be solving a non-homogeneous differential equation. However, this will be very simple. Just to get the method down, I would recommend using the other integration methods such as separable variables, because this is a linear separable differential equation. And we will have an initial condition when y is 0 of 2.5. So solving this, I'm just rewriting our differential equation using the Laplace transforms. And looking at our table, we get this. Again, this is given to us through given by Laplace transformation chart. Okay, so just doing some simple algebra here, I'm going to be rearranging this equation so that it's easier for us to solve. One thing to note is be careful if you're arithmetic, because when you are moving things on different sides of the equal sign, you just got to be careful of the positive and negative integers. And so we just factor out a y here because they share a common variable. Okay, now moving on, we get y 1, 5 plus 2.5 over s plus 2. Okay, so now that we have this transform, we will be finding the inverse Laplace transform, denoted by the function of y of t, and the inverse Laplace is denoted by a -1. And then we set this equal to. Okay, so here we will be expanding fractions, partial fraction expansion, which is covered in multivariable. So essentially, we just remove all numerators and replace them with constants. So we have a plus b, and then since 2.5 is on the other side of the equal sign, we have to keep 2.5. Okay, great. So we just rewrite the denominators. And I will be using the shortcut method because this equation right here allows for it. Otherwise, you could choose using smart numbers to isolate and solve for your variables. So solving for the variables using the shortcut method, we get this. And we will let s equals 0. And when s is equal to 0, b cancels out. Therefore, we get this. And this ultimately turns into a equals 1/2. So now we have our a. Now let's isolate b. So b is s over s plus 2. So how do we get rid of that? We let s equal to -2. And then we get this. B is equal to -1/2. So then finally, we rewrite with all of our variables that we solved for. Whoops. And now it's just simplifying. We get 1/2 minus 1/2 e -2t plus 2.5 e to the -t and this equals 1/2 plus 2e minus 2t, fully simplified. And once again, this is given to us through the Laplace chart. And so I guess this can be broken up into 3 steps. Oh, sorry, I meant to say that this is my final solution. And we will be breaking down, or I will be breaking this down into steps for us. So step 1 would be Find the transform of everything. In this case, it was our homogeneous differential equation. Step 2, solve for the unknown transform capital Y of S. And then our final step would be y of t is the inverse transform of capital Y of S. Okay, so this concludes my submission video for Math 2500. Thank you for watching, and I will be uploading this to Brightspace for further evaluation. Thank you for your time.